Gresa. Well, that's the way we say hello in Switzerland. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, here, children, this is binomial theorem that we are discussing. Now, we have already had one lecture where we discussed the basics, the formulae, and also rather a single sum. Now, children, we'll be discussing further sums. So quickly revise all that we studied, and then we will start off with the next sum. Now, children, to tell you about the formula, remember we talked about the binomial theorem, which now is this: that if suppose we talk about, say, x plus a raised to the power n, then that becomes equal to nc0 x raised to the power the difference of the numbers in the superfix and the suffix times of a raised to the power the number which is in the suffix. To that is added nc1, right, which is again the binomial coefficient, times of x raised to the power the difference of the numbers in the superfix and in the suffix, times of a, which is the second term, raised to the power the number in the suffix, and all of this continues up to the last term, which is ncn, the binomial coefficient, times of x raised to the power the difference of the numbers in the superfix and the suffix, that is n minus n, times of a raised to the power the number in the suffix, that is n. Right? So this, children, is the binomial theorem, and using this we are now going to do a few sums. So now at the moment, the first sum that I have for you people is something like this. So I will give you 10 seconds for trial, after which we will be discussing the sum. Okay, children, now let's discuss the sum. Here, children, we have to expand in place of a binomial, a trinomial. But if you look at this binomial, this looks to be a little familiar. For that matter, if we try to write this, we can write this as 1 squared, and to that you can add plus 2 times of 1 times of minus x, so that will give you minus 2x, right? And further then you can talk about the next term to be, say, some minus x, which is whole squared. Now all of this is raised to the power 3. As such, now you can write this to be 1 minus x whole square, and we have the whole power of this to be 3. Right? So as such, children, we can write this to be 1 minus x, which is whole raised to the power 6. Right? As if you remember the formula that you studied in indices, if you have a raised to the power m, which is whole raised to the power n, then that becomes equal to a raised to the power m into n. Right? As such, here 3 and 2 have got multiplied to become equal to 6. Now we will quickly be reminded of the binomial theorem, which says that if we have a binomial like x plus a raised to the power n, then that becomes equal to nc0 x raised to the power n times of a raised to the power 0 plus nc 1 times of x raised to the power n minus 1 a raised to the power 1, and all of that is going to continue up to the last term, which is going to become equal to ncn, right, x raised to the power 0 a raised to the power n. Right? So using this binomial theorem, now we're going to expand 1 minus 6 raised to the power 6. Right? Now further, when we expand this 1 minus x raised to the power 6, we can write this as 6c0 1 raised to the power 6 minus x raised to the power 0, which will eventually become equal to 1. To that is to be added 6c1 1 raised to the power 5 minus x raised to the power 1, plus we have 6c2 1 raised to the power 4 times of minus x raised to the power 2, and then the next term is going to be 6c3 minus, it will be 1 raised to the power 3, and then to this you have multiplied minus x raised to the power 3. The next term, children, is going to be 6c4. You have 1 raised to the power 4. With that is multiplied minus x raised to the power, not 4, but we have here 1 raised to the power the difference of 6 and 4, that is 2, and we have times of minus x raised to the power the suffix, that is 4. To that is added the second last term, which will be 6c5 1 raised to the power 1, right, and to that is going to be multiplied minus x raised to the power 5, and finally we will have the last term, which is 6c6 1 raised to the power 0 and minus x raised to the power 6. So all of these are going to be the terms. Now our next task is to find out the value of the binomial coefficients and get to the final answer. So now quickly calculating the binomial coefficients. So if we talk about 6c0, then 6c0 will become equal to 6 factorial, which is to be divided by 6 minus 0 factorial times of 0 factorial. So this, children, is going to become equal to 6 factorial divided by 6 factorial times of 0 factorial is 1. As such, both of these cancel each other, and thus the first binomial coefficient will become equal to 1. For that matter, always remember that whenever you talk about the first binomial coefficient, it always comes to 1 for the value of n to be a natural number, right? In times to come, obviously, we will be talking about the binomial theorem when the value of n is a fraction. At the moment, you just have to concentrate when we talk about the value of n to be a natural number, right? Now next, children, we are going to talk about the next binomial coefficient. So if we talk about 6c1, that is going to become equal to 6 factorial divided by 6 minus 1 factorial times of 1 factorial. That is going to become equal to 6 times of factorial 5 divided by factorial 5 times of 1 factorial, that is 1. So here further 5 factorial will get cancelled, and this will become equal to 6. Right. Next, now we talk about 6c2. 6c2 is going to become equal to 6 factorial divided by 6 minus 2 factorial times of 2 factorial. This thus is going to become equal to 6 multiplied by 5 multiplied by factorial 4 divided by factorial 4 and multiplied by 2 into 1. So factorial 4 is going to get cancelled from the numerator and from the denominator. 2 will get cancelled with 6 3 times. 3 into 5 is going to become equal to 15, and this will thus become the next binomial coefficient. So after this, children, remember I told you people that if we talk about the binomial coefficients, we have certain binomial coefficients which will be repeating. For that matter, if we talk about the first binomial coefficient, it is going to be equal to the last binomial coefficient, right? As such, now here, if we talk about 6c0, it is going to match with the value of 6c6. Then if we talk about the value of 6c1, it is going to match with the second last binomial coefficient, that is 6c5. And similarly, when we talk about the binomial coefficient, which is 6c2, it is going to match with the third last, that is 6c4, right? So the last one that we've got to calculate is actually just 6c3, and except that we have the other binomial coefficients to be matching. So next, now we will be talking about that binomial coefficient which matches with 6c0, that is the one which has been marked with tick, and that, children, is 6c6. Now if we talk about the other binomial coefficient which matches 1, so that will be the second and the second last, that is 6c1 is going to be equal to 6c5. And then further, if we talk about the next one, which is 6c2, then that matches with the one which has been marked with hash, that is 6c4. Right now, after this, children, next now we talk about the last one which requires to be calculated, and that is 6c3. So this is going to become equal to factorial 6, which is going to be divided by factorial 3 and to be further multiplied with factorial 3 in the denominator. Now this we can write as 6 into 5 into 4, which is further multiplied with factorial 3 and to be divided by factorial 3 multiplied by factorial 3, which can be written as 3 into 2 into 1. Now 3 to 2 becomes equal to 6, which cancels with 6. Factorial 3 and factorial 3 also gets cancelled, so 5 into 4 will become equal to 20, and that, children, is the next binomial coefficient, 6c3. Now that we have all of these binomial coefficients, we're going to keep their values in their proper places. So we will get to our final answer, which now comes to here First 6 is 0, which is equal to 1, right? And it is going to be multiplied with 1 raised to the power 6, which obviously will remain to be 1. Then it is going to be multiplied with minus x raised to the power 0, and any number raised to the power 0 is going to be 1. So as such, the first term will remain to be 1, and then after that we talk about the second term, which is 6c1, and 6c1 has been calculated to be equal to 6, so we substitute its value, and after that 1 raised to any power will remain to be 1, and then further it is multiplied with minus x. Next, now after this we talk about the next term, which is 6c2. So 6c2 is equal to 15. So now we keep this value, which is 15, we multiply it with 1 raised to any power, that will remain to be 1, and further to be multiplied with minus x raised to the power 2, right? So we write this now, minus x raised to the power 2. Now when we talk about the next term, it is 6c3. The value of 6c3 we calculated to be 20, and that is going to be multiplied with 1 raised to the power 3, which will remain to be 1, as 1 is multiplicative identity. As such, there is no point writing it, and we multiply it with minus x, which is going to be raised to the power 3. Further to that, we're going to add here now the next binomial coefficient, which is 6c4. Its value is the same as 6c2, which is 15. So next now we have 15 times of 1 raised to the power 2, which will remain to be 1, and further to be multiplied with minus x raised to the power 4. Right? And after that we talk about now the next binomial coefficient, which is 6, which is to be multiplied with 1 raised to the power 1, which will again remain to be 1, to be further multiplied with minus x raised to the power 5, and to that is going to be added now the last term, which is 1, the value of the binomial coefficient 6c6, right, to be multiplied with 1 raised to the power 0, that is going to be 1, and to be further multiplied with minus x raised to the power 6. As such, we will just have minus x raised to the power 6. Now after this, children, we have to calculate finally to get to the answer. So in the next step now we will have the final answer, that is 1, and then we have minus 6x, then we have plus 15x square, right, and then minus 20x cube, and then plus 15x raised to the power 4, and after that minus 6x raised to the power 5, and then we have plus x raised to the power 6, and that, children, is going to become the final answer, right? So this is how we solve this question. Now we will quickly look this up so that if there is any doubt which is withstanding, all of that fizzles away. So in the question, children, you have been given that you have to expand 1 minus 2x plus x square whole raised to the power 3. In the first look, this looks to be a trinomial which has been raised to some power. So I'm sure you must be wondering, what is this a question? We just studied the expansion of a binomial. How can we find out the expansion of a trinomial? But if you talk about this binomial, it can be converted to, if you talk about this trinomial, it can be converted to a binomial. How so? If you talk about 1, we can write it as 1 square. Then further, if we talk about this minus 2x, we can write this as plus 2 times of 1 times of minus x, which eventually will give you minus 2x. As such, here we get the value of a to be equal to 1. The value of now the 2ab term, which is 2 times of a times of the value of b, will become equal to minus x. As such, next now we write minus x whole square, which is the b square term, right? So now further we can write this as 1 minus x whole raised to the power 2, and the whole power of this is 3 like earlier. So as we have a raised to the power m whole raised to the power n, which becomes equal to a raised to the power m into n. As such, here we will have this to be 1 minus x raised to the power 3 into 2, which is 6, right? Further then, next we talk about the binomial theorem, which you study like a formula, right? And then now we apply it to this case. So we first write the binomial coefficient, which comes first, that is 6 is 0, right? Just like NC0. The first term raised to the power the difference of the superfix and the suffix, that is 6 minus 0, that is 6, and the second term, that is minus x. Remember to carry the sign, right? So minus x raised to the power the suffix, that is 0, right? And similarly we will be able to write each and every term like I explained earlier up to the last term, which is 6c6, right? The first term raised to the power the difference of the superfix and the suffix, that comes to 0, and the second term minus x raised to the power the number which comes in the suffix, that is 6. So this is the complete expansion. Now we require to find it as normal terms, right? So first, for that we require to find out these binomial coefficients. So when we talk about 6c0, like explained earlier, it is going to be factorial of the number which is there in the superfix divided by the product of the difference of the numbers in the superfix and the suffix factorial times of factorial of the number which is there in the suffix, right? So here further this calculates to 6 factorial divided by 6 factorial into 1. So 6 factorial gets cancelled. You just get this to be equal to 1. Now this becomes equal to 6c6. Why so? Because the first binomial coefficient is equal to the last binomial coefficient. You can calculate this and check this. It will come to be the same, right? So if it is 6c0 or if it is 6c6, you will replace its value to be 1, right? Next, now when we talk about 6c1, its value is the same as the second last one, the third with the third last one, and they've been represented by similar type of signs, right? So the next one, that is the last one that we require to calculate, is actually 6c3, which next we calculate in a similar way. Now after this, we now keep the values of these binomial coefficients and further simplify these powers, where it is minus x raised to the power 3. So obviously it can be written as minus 1 raised to the power 3 times of x raised to the power 3, as minus 1 raised to the power 3 will become equal to minus. So as such, it will become equal to minus multiplied with this number 20 times of x cubed. Right? So this is how, children, we are able to get the value of these binomial, right, expansions by using the binomial theorem, as this is the second sum. So I'm sure now you are getting a better idea how to go about with the sums. So are you all clear? Is everybody clear? Daniel? Sure? Okay guys, now after this we are now going to discuss the next sum, and the next sum goes something like this. We have to expand a minus b plus c whole raised to the power 4. Now in order to find out this expansion, again I was just going to discuss the solution, but I like to give you people 10 seconds for trial. If you require more time, then what you can do is you can pause the lecture and give it a better try. For that matter, do remember that whenever you are studying, make sure to sit in a secluded place all by yourself, disturbed to be by nobody, right? Make sure your parents are also told that you are studying in seclusion, and make sure you don't do anything else so that you don't break their confidence, right? Sit straight with your spine straight. Don't keep a book or a copy in your hand, rather close them so that that doesn't divert you, right? And study exactly where my pointer is. As such, then you will be able to understand the maximum, right? And after the sum has been done, immediately pause the lecture and quickly give the sum a trial all on your own, and wherever you get stuck up, then look up the solution. Okay, so now children, I'll be giving you 10 seconds for trial, after which I'll be discussing the sum. Okay children, now let's discuss the sum. In the question, we've been given a minus b plus c whole raised to the power 4. And here you get to see that there is no recluse here. We will be treating this trinomial like a trinomial. That means you indeed have to find out some other way so that we can use the binomial theorem. So what exactly do we do here is we can now make the first two terms to be considered to be a single term, right? For that matter, if say you talk about this a minus b plus c, which is whole raised to the power 4. Now here what you can do is you can consider this a minus b to be a single term, right? As such, this now is just like a binomial x plus a raised to the power n. So quickly we will be reminded about the formula, that is when we talk about x plus a, which is raised to the power n, then that is going to become equal to nc0, the first term raised to the power the difference of the superfix and the suffix, that is n, times of the second term raised to the power the number in the suffix, that is 0. To that we are going to add nc1x raised to the power the difference of the superfix and the suffix, times of a raised to the power 1, and then we talk about adding the terms like this in order following this formula, right? And then we get to the last term, which is ncnx raised to the power 0 a raised to the power n. And this, children, is the expansion of the binomial theorem, which now we are going to apply to this trinomial, which has been converted to a binomial. So next, now what we do is first we talk about 4c0, and then we have a minus b, which has been raised to the power 4, which is further multiplied with c raised to the power 0. Then the next is 4c1 a minus b raised to the power 3 times of c raised to the power 1, plus we have 4c2 a minus b raised to the power 2 and c raised to the power 2. Then we have 4c3 a minus b times of c raised to the power 3, and then we have the last term, which is 4c4 a minus b raised to the power 0 and c raised to the power 4. So this, children, is the expansion of the binomial, where we considered a minus b to be a monomial and c also to be a monomial. Thus this got converted from a trinomial to be a monomial, to a binomial. Now remember, children, here this monomial that we are talking about, a minus b, has been coupled together or has been kept together by this horizontal bracket. If you just try stressing a little, remember in BODMAS you studied 4 type of brackets, right? One was the curly bracket, then you talked about the box bracket, then we had the simple bracket, and also this horizontal bracket. So this is the horizontal bar bracket, right, which represents a bracket for that case. Okay, now, children, here next we talk about the expansion of all of this. Now you get to see here that we have here a minus b raised to the power 4, a minus b raised to the power 3, which also need expansion by the same binomial theorem. So this is now what is going to be simplified and will thus help in removing the confusion. So next, now we can write this as 4c0, which is going to be multiplied with, now in the bracket we are now going to expand a minus b raised to the power 4, which is going to become equal to 4 c0 a raised to the power 4 and minus b raised to the power 0. To that we are going to add 4c1 a raised to the power 3 and minus b raised to the power 1. To that we are going to add 4c2 a raised to the power 2 and minus b raised to the power 2, and all of that is going to continue up to the last term, which is 4c4 a raised to the power 0 and minus b raised to the power 4, and this now is also going to be multiplied with c raised to the power 0, as c raised to the power 0 is the same as 1, which is multiplicative identity, so we need not write it. Now after this, children, we'll be talking about the next term, which is 4c1, and remember it requires to be multiplied with a minus b raised to the power 3, which can be written as 3c0 a raised to the power 3 minus b raised to the power 0, right? To that is going to be added 3c1 a raised to the power 2 minus b raised to the power 1, plus we have 3c2 a raised to the power 1 and minus b raised to the power 2, and to that is going to be added 3c3 a raised to the power 0 and minus b raised to the power 3. And children, this is all, remember, this also requires to be multiplied with c raised to the power 1, which is the same as c, right? And further after this, we now require to multiply 4c2, right, which is something like this, with a minus b whole square, and that, children, is a child's play for you people, as we know its value to be a square. Then we have minus 2ab plus b square, where you need not apply the binomial theorem, just multiply it with c square, and that's about all. Then after this, we now talk about 4c3, right, and 4c3 is then to be multiplied with a minus b, right, and which further is also to be multiplied with c raised to the power 3, right, which is this term. And then lastly, we talk about now 4c4, right, which is to be multiplied with a minus b raised to the power 0, which will become equal to 1. 1 being multiplicative identity, we can avoid it. And then this requires to be multiplied with c raised to the power 4, and that, children, is the expansion. Further, if all of these are multiplied together, then we will get to the expansion of this binomial, right? So next, now what is, we will just try and simplify this a little by first calculating the binomial coefficients and further multiplying, right? So next, now what we do is we calculate the binomial coefficients. When we talk about 4c1, children, that is going to become equal to, rather, remember, we don't require to calculate 4c0 or 4c4 because we know its value is going to be 1, right? Like I discussed in the last sum, whenever we talk about the first binomial coefficient or the last binomial coefficient, it always comes out to be 1. Now, when we talk about 4c1, that then is going to become equal to 4 factorial divided by 4 minus 1 factorial times of 1 factorial. This, children, is going to become equal to 4 times of factorial 3 divided by factorial 3 and multiplied by 1, which can be forgotten as 1 is multiplicative identity. So this, children, comes to 4, and remember, this is going to be equal to the second last binomial coefficient, or in other words, it is going to be equal to 4c3. Next, now we talk about 4c2. So 4c2 is going to be equal to factorial 4 divided by factorial of 4 minus 2 times of factorial 2. So that then becomes equal to 4 times of 3 times of factorial 2, which is to be divided by factorial 2 and further to be multiplied by factorial 2. Right now, factorial 2 gets cancelled with factorial 2, then factorial 2 is 2 into 1, which will get cancelled with 4 2 times, right? So 6 becomes the value of 4c2, right? And here, thus, we have this to be the third binomial coefficient, right, whose value is this, right? So next, now, children, we will be keeping these values in their places, and after that, by multiplication, we will get the corresponding values. So here, after this, our next step is going to be this multiplication, right? Next, now we talk about finding out the next binomial coefficient. That is, we will now be talking about 4c3, right? So 4c3 will then become equal to factorial 4 divided by 4 minus 3 factorial times of, here, 3 factorial. So for the children, this becomes equal to 4, which will be multiplied with factorial 3 and then divided by factorial 1, which is 1 multiplicative identity and thus forgotten, divided by factorial 3. Both of these factorial 3's will get cancelled, as such this will become equal to 4. Now we will quickly be reminded that the first binomial coefficient is equal to the last, the second is equal to the second last, the third is equal to third last, and apply it quickly. So here further, we talk about the first binomial coefficient to be equal to the last, that is 4c0 is equal to 4c4. Further, we talk about 4c1, which is then going to become equal to the second last, right? And the second last, children, is 4c3, right? So here, as such, we can write this to be equal to 4c3, right? And then next, we talk about here the next one, that is, I'm going to write this with a different color so that you can easily identify the ones which are equal, right? And similarly, then, if you talk about 4c3, right? Then next we have the third last, right, which is falling to be the term in the center. As such, we are not going to talk about this, right? So we find out the value of this, and we've just seen that if we talk about the value of 4c3, it is coming to be exactly the same as 4c1, right? So next, now after calculating all of this, we now substitute their values, right? So the first one that we have is 4c0, that is 1, right? So now writing the next step, that is, we have 1 which gets multiplied with 4c1, which is again 1 to be multiplied with a raised to the power 4, b raised to the power 0 for that matter, minus b raised to the power 0 is going to be 1. And then further we talk about adding to this the next term, which now is going to become equal to minus times of, as we have minus b times of 4c1 is 4 times of a cube times of b, right? Then we talk about the next one, which is 4c2. We have calculated 4c2 to be 6, right? So next we have 6 times of a square times of, as there is minus b whole square, so obviously it will become equal to b square, right? So further it will be multiplied with b square. Next, children, after this we talk about the next one, which is going to be 4c3, right? 4c3 is the same as 4c1. As such, it will become equal to 4. But since we are now going to have minus b whole cube, as such we will have minus b. This is going to be multiplied with a and b raised to the power 3. Next, children, we come to the last term, which is 4c4, that is 1 times of a raised to the power 0, that will also become equal to 1, and further minus b raised to the power 4 will become equal to b raised to the power 4. So next, now we write added to this plus b raised to the power 4, and this, children, is the expansion. Next, after this we require to multiply 4c1, right? Remember, now we are talking about this step, so we now require to multiply 4c1 with these 4 terms. Now 4c1 we've already calculated to be 4, right? And that, children, we're going to now multiply with 3c0, which will be 1 multiplied with a raised to the power 3, as minus b raised to the power 0 is going to become equal to 1. Next, then we talk about the next term, which is 3c1, that is 3, which is going to be multiplied with a square, and since it is getting multiplied with minus b, so we will have b here, and we will then change this plus sign to minus sign, right? Now after this we talk about the next term. Now the next term we get to see is 3c2, right? So 3c2 is going to be the same as 3c1, because the first term's value, right, for the binomial coefficient is going to be equal to the last term's binomial coefficient. The second term's binomial coefficient will be equal to the second term's binomial coefficient, right? So further, children, we will say that as 3c1 is going to become equal to 3, thus 3c2 being the second last, its binomial coefficient also is going to be the same as the second one, that is 3. So we will now have 3 times of a times of b square, right? That is the next term. So plus 3 times of, we have a times of b square, right? And then after that we talk about the next one, which is going to become equal to 3c3, that is 1 times of a raised to the power 0 is 1 times of minus b cube, right? And this is minus b cube. And now, children, if you match, this is exactly the same as a minus b whole cube, the formula that you learnt, that is a cube minus b cube minus 3a square b plus 3ab square, right? After this, children, next now we talk about 4c2, right? And 4c2 we've just calculated to be 6. So next now we have 6, which is going to be multiplied with a square minus 2ab plus b square, right? So next then we will be multiplying this, and remember, this is also to be multiplied with c square, right? And the earlier term is to be multiplied with c. Remember, there was also a c outside, so as such we require to put up a c here, right? And thus putting up a c here. Next then, after that, now we talk about the last term, which is now, the second last term. 4c3 is going to again become equal to 4. It will be multiplied with a minus b to be further multiplied with c cube, and to that is to be added 4c4, which is going to be 1 times of c raised to the power 4. So just c raised to the power 4, that is the last term. Now children, we will further simplify this and get to the sum of the like terms. So now we have a raised to the power 4 minus 4a cube b, right, plus 6a square b square minus 4ab cube plus b raised to the power 4. Then we have plus 4a cube minus 12a square b, right, and then we have here plus 12ab square and minus 4b cube, right? And remember, all of this is to be multiplied with c, right? This c, which is at the end trailing, is to be multiplied with all the terms. As such, now we multiply all of these 4 terms that we have written to be multiplied with c. As such, we have a cube c, a square b c, then we have a b square c, then b 4b cube c. Now lastly, we now have this 6, which is multiplied with c square, and then further with the terms a square minus 2ab plus b square. So next now we have plus 6 a square c square minus 6 2 is 12 a b c square, and then we have plus 6 b square c square, and then further after that we have plus 4c cube. Rather, we'll write a first, a c cube, and minus 4b c cube, and then further we have plus c raised to the power 4. Now will be our turn to find out the like terms. So if we talk about the like terms, we start out with the first one, that is a raised to the power 4, and I don't think any term is going to have a raised to the power 4. It is not. So as such, a raised to the power 4 is going to be written lone, right? Next we try and search for a cube b, right? So we try searching for a cube b, and there is no term with a cube b. So as such, here we will write this to be as it is, that is minus 4 a cube b. Then we search for the term which is a square b square, right? Now we do not get a term which is a square b square. Now we put up a quick search whether there is any term which is a like term or not. Otherwise we will put this to be the final answer. So a b cube, now a b cube is also not to be found, so as such it will also remain to be lone. And then we have b raised to the power 4, b raised to the power 4 also cannot be searched for. Then further we have a cube c, a cube c also cannot be searched for, right? Then we have a square bc, a square bc is also not available. As such, now we can first finally say that none of these terms are like terms. As such, this that we found out will come to be our final answer, right? And we can now rightly say that we already found out the final answer, that is the last step, and this, children, is going to become the final answer. So I'll just quickly discuss all of this again. Right, this looks to be a little crooked, but if you do step by step, then I'm sure very easily you will be able to crack this sum. We have a minus b plus c whole raised to the power 4. Why this power 4? Because if it would have been a minus b plus c whole raised to the power 3, very easily you could have written the cube of this, right? So that is why this power 4 is there. And now if you look up this trinomial, this cannot be factorized like what we did in the last sum. If you remember the last sum, in the last sum we had here 1 minus 2x plus x square, which could have been factorized like 1 minus x whole square. Contrary to that, if you talk about this, here we cannot find out this to be factorized. As such, now what we do is we take the first two terms to be one term, Then we talk about the other, which is already one term, to be the next term. As such, this trinomial gets converted to a binomial. And after that, children, now we apply the binomial theorem, which is x plus a raised to the power n is equal to nc0 x raised to the power difference of the superfix and the suffix times of a raised to the power the number in the suffix. And all of this is going to continue up the last term, which I'm sure by now you must have learned pretty well. So we apply this to this given expression, right? And then here a minus b is treated as the first term and c is treated as the second term, as we did in the general expansion of the binomial x plus a raised to the power n, right? After that, children, we find that each of these individual terms also require binomial expansion. So as such, we apply binomial expansion to a minus b whole raised to the power 4, likewise in the form of the formula, right? And then we have a minus b whole raised to the power 3, so we apply that too. Right here, you can eat up a step by just directly writing the value of a minus b whole cube, that is a cube minus b cube minus 3a square b plus 3ab square. Further, similarly, the square of a minus b formula has been directly applied, right? Remember to multiply the second term's such powers as is required in that specific term, and then after that we put up a proper multiplication, right, after finding out the different binomial coefficients, which I'm sure by now you must have perfectly understood. For that matter, we will quickly try to calculate the value of 4c3. So 4c3 will become equal to 4 factorial divided by the factorial of the difference of the superfix and the suffix times of the factorial of the number which is there in the suffix, right? Then 4 factorial can be written as 4 times of factorial 3. Factorial 3 will get cancelled from the numerator, and from the denominator, factorial 1 is just 1. So we have 4 upon 1, which will become equal to 4. This is how the different factorials will be calculated. For that matter, do remember that if we talk about the first binomial coefficient, it will become equal to the last binomial coefficient. So if we talk about 4c0 and if we talk about 4c4, they are one and the same. Similarly, if we talk about 4c1 and 4c3, which is there in this dot 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 space, right? So even that will have the same value. So here, quickly writing this term. So we can write this now, the second last term as 4c3, we will have a times of minus b whole raised to the power 3, right? So that is going to be added the next term. And here, children, we get to see that if you talk about this binomial coefficient 4c3, it will be exactly the same as the binomial coefficient 4c1, right? So both of their values have been calculated below, which has come to 4, right? Next, children, we talk about keeping the value of these binomial coefficients, multiplying them with the corresponding terms, right? And after that, we try to find out the sum of the like terms, which we find to be none. Obviously, it is customary to find out whether there are some like terms or not. So we did start off that process, but as it is possible in certain sums, there are no like terms. So here we didn't get any like terms. As such, we just kept this answer to be as it is, which becomes the final answer. So I hope you people have been able to understand this. So this is how binomial theorem goes and how we go ahead with the different sums of binomial theorem. So children, I'm sure you people also must be pausing these lectures and also giving the sums a try, so that if such sort of sums come in the exam, you are able to do them pretty well. Right? Remember, if you practice much, then obviously when you write your answers in the final examination, it is going to come out to be pretty sleek and smooth. Right? So bye children, have a nice time, do practice. Bye.